Hello, ray optics. First topic here is reflection. Laws of reflection. First law, angle of incident is equal to angle of reflection. In reflection, rays bouncing back to the same medium where there is no change in the frequency and wavelength. C is equal to nu lambda. C is the speed of light, nu the frequency here, and lambda is wavelength. Second law, incident ray, normal, and the reflected ray all are the same plane. First, plane mirror. Here focal length and radius of curvature is finite. Suppose this is the object, this is the image, they are equal distance from the plane mirror. Suppose object is moving with velocity, approaching the mirror also moving same speed but in opposite direction. In plane mirror, image is formed, that is the virtual erect and at the same distance is moving with same velocity in opposite direction. But they are literally, it is literally inverted, left to right, right to left. Like see here, suppose in ambulance it is written this sequence. In image we are getting the correct spelling. Yeah? So it is literally inverted, left and right. And suppose you want to see the whole image of yourself and your height is from eye to the head, that is 2x, up to this is 2y. So from the ray diagram we can see here the size of the image should be x plus y, where size of yourself is 2x plus y. So half size of the image mirror is required, plane mirror is required to see our full image. So size of the mirror is required to see fully our image is half of the size of ourselves. When a point object is held in between the two mirrors M1 and M2, they are separated by the angular distance theta angle, and O is the object placed here. So number image will be seen. Formula here is n equal to 360 upon theta minus 1. If 360 upon theta is even in number, then we'll use this formula to find out the number of images. If 360 by theta is odd number, then we'll use this formula to find out the number of images formed of this single. Suppose here this mirror position number 1, image is formed here I1 of this object, angle I is equal to angle R. If we rotate the mirror by an angle, say by an angle theta, then this image is rotated by angle theta. Because in this position, from this new normal and 2, angle of incident is I plus theta, not I. Similarly, R will be I plus theta. So 2I plus 2 theta. So here I plus R 2I, but here angle means if the mirror is rotated by angle theta, image is rotated by angle theta. When ray is coming, incident ray, this is the reflected ray. So this ray is deviated by an angle of 180 minus 2 theta. Theta, theta, 2 theta, 180 minus 2 theta is this. So this in this reflection, ray is rotated by an angle of 180 minus theta. The relation between the focal length and the radius of curvature. Very, very simple of 10th class, not of 12th. But anyway, this is the incident ray on concave mirror passing through the focus, say from C. This angle I is equal to angle R, law of reflection, first law. This I and this I is what? Alternate angle. Then this triangle CBF. This angle and this angle, they are equal, I is equal to R. So this triangle CBF, this is isosceles triangle, I is equal to R, so opposite sides are also equal. CF is equal to FB, and aperture is small, so FP is equal to what? FB. From these two, we can say here CF is equal to, so PC is equal to PF plus FC, and CF की जगह PF लिख दिया, so CP is equal to R is equal to what? To F to F. So R is equal to F or F is equal to R by. It is true for any mirror, whether it is concave mirror, convex mirror or plane mirror. Now deriving the mirror formula here, and there are three cases we have taken: concave mirror and the real image formed. Here AB is of the object placed beyond C. Image is formed here in between and F. By the ray diagram, we can see parallel is passing focus, is passing through the C, it is reflected back, it is ray BP, front ray at an angle of I, angle I is equal to R, passing through the B dash. After reflect, so A dash B dash is the image and this is the object here. In similar triangles, pair of similar triangle, triangle ABC and A dash B dash C. Both are similar triangle, so similar triangle property, A dash B dash upon AB, size of image upon size of object by the corresponding side ratio A dash upon CA. CA dash, every distance is measured from pole, so CA dash and CH replaced like minus P dash and CA will be PA minus PC, equation 1. In another pair of similar triangle ABP and A dash B dash P, again A dash B dash upon AB by the corresponding side ratio A dash upon A, equation 2. Here in equation 1 and 2, left hand side A dash B dash upon AB is same for both equation, so right hand side must be same. Here PC minus PA dash upon P minus PC and here PA dash upon PA, we are putting the distances with sign convention. PC means minus R, this is minus V, A is minus U, P star minus V minus U, minus cancel out. So here after the cross multiplication, we are getting 2FU plus VU, here minus UV plus 2FV, UV एक साइड उधर ले गए लेफ्ट की तरफ, तो 2UV इस इधर आ गया, 2FU plus 2FV and every term is divided by 2VU. That will cancel out 1 by F, 1 by V, 1 by U. This is the mirror formula. And for the linear magnification M, size of the image HI upon HO, A dash B dash upon AB from the second equation. Using the second equation, P dash upon PA, sign convention value V by U minus cancel out. So this is the linear magnification given by equation 4. Now the second case we are taking here, concave mirror and virtual image. We are going to derive in this case also the mirror formula and magnification. Here, this is the concave mirror. We place the object AB in between focus and the pole with a parallel line passing through the focus, and this passing through the C center of curvature, it is bouncing back, like bouncing back. And BP ray, incident ray, and this is refracted ray. They are not meeting because of the diverging in nature. They are appearing to be meeting somewhere here. So A dash B dash is the virtual image, direct image and the magnified image. When we place the object in between focus and pole, we are getting virtual. Now there are two pairs of similar triangle ABC and A dash B dash C. Again A dash B dash upon AB, always यही ले रहे हैं हम लोग हमेशा. Corresponding side will be A dash upon PA. डिस्टेंस P से लेनी है तो इसको रिप्लेस कर दिया P dash plus PC. A की जगह हमने लिखा PC minus A. In another pair of similar triangle A dash B dash C and ABP, again A dash B dash upon AB will be A dash upon A. Corresponding side ratio from equation 1 and 2, left hand side A dash B dash upon AB, same for both the equations, so right hand side must be same. We have taken from equation 1 and 2, A dash plus PC upon PC minus PA, A dash upon PA. Putting the values of UVR with the sign convention here, A dash plus V, PC will be minus R, PA will be minus U. Putting here, and after cross multiplication, we are getting this minus 2FU P and plus UV and minus UV minus plus 2F. इसको इधर ले गए, अगेन डायरेक्ट टर्म को 2 से डिवाइड किया, कैंसिल आउट होने के बाद इक्वेशन 4 मिल गई. द सेम मिरर फार्मूला. या कोई भी केस हो, मिरर फार्मूला विल बी द सेम फॉर मिरर, सिमिलरली लेंस फॉर सेम फॉर लेंस. And magnification will be linear magnification HI upon HO, height of image upon height of object, A dash B dash upon AB, A dash upon A, V upon minus Q. So this is the formula of equation. We are going to derive again the same mirror formula for convex mirror and the virtual image. This is the convex mirror. AB is placed anywhere, we are getting always the virtual image erect and diminished. This is the ray diagram passing the focus, it seems to be coming back from the focus, and if it is passing through the C central curvature, bouncing back, somewhere meeting imaginary A dash B dash. So BP incident ray, and this is the reflected ray somewhere. So this is the finally A dash B dash, the virtual erect and diminished image. In similar triangle ABC and A dash B dash C, corresponding side ratio A dash B dash upon AB, it will be A dash upon A. But में डिस्टेंस तो पी से लेनी है पोल से, सो रिप्लेस हियर सी डैश लाइक पी सी माइनस पी डैश, सी को हम क्या लिखेंगे दिस पी सी एंड पी ए. Similarly for similar triangle A dash B dash P and triangle ABP, ratio is always A dash B dash upon AB, it's P A dash upon A. Question 1 and 2, left hand side is same here, right hand side must be same. So here PC minus PA dash upon PC plus PA dash upon, putting the value of UVR with sign convention, and R is equal to F. So PC is positive R, this is minus V plus V, A minus U. Thing here and R की जगह 2F लिख दिया. After cross multiplication, we are getting here 2FU plus UV and 2FV minus U. तो UV एक तरफ ले लिया, हर टर्म को 2F डिवाइड के ऐसे पहले करते हैं हमेशा सिंपल. तो 1/F is equal to 1/V plus 1/U. This is the mirror formula. Linear magnification, height of the image upon height of the object, A dash B dash upon AB, A dash upon PA, the sign convention, magnification formula coming here, V upon minus U. Can be written this way also, in terms of focal length and V image distance, in terms of focal length and object. And now refraction. The refraction of light means is the phenomena of bending of light when it enters a medium from the different optical densities. If it is moving from rarer to denser, the ray must bend towards the normal. It is moving from denser to rarer, it is moving away from the normal. The laws of refraction, first law, Snell's law, we are moving in medium 2 from medium 1, then it's sin I upon sin R, mu is the refractive index here, this is in relative term. Now, suppose the incident ray, normal and refracted ray all lie in the same plane. This is the second law of refraction. So, taking this case, is the glass slab moving from medium 1 to 2 and again medium 1. What is rarer, denser medium, it is moving, bending towards the normal. From denser to rarer, it is moving away from the normal. If the first and the last term is same, and this angle I must be equal to angle of emergent E, and the incident ray is produced here, this ray incident and the produced emergent parallel. So mu is equal to what? Speed of light in air upon speed of light in T. Relative refractive index is what? Mu is equal to speed of light in upon medium 2 and mu 2 upon mu1 is mu1. Here lateral shift, important part, this derivation may come, board examination and question also. Very simple. It is called lateral shift. Here is the incident ray when produced and the final emergent ray. If the first and the last medium is same, these two rays must be parallel and I is equal to E. And this perpendicular distance between the two parallel rays is called lateral shift or lateral displacement. We have taken a glass slab of thickness T, the incident ray incidenting at angle say I1. So delta is the angle of deviation. Delta is equal to what? Opposite angle, vertical opposite I1 minus R. Say I ले लेते हैं, I minus R. So sin delta will be ms upon lambda. Now sin delta will be this triangle LMS, sin delta ms upon LM. So after cross multiplication, MS lateral shift will be LM sin delta. In triangle L dash M, cos R will be base LL dash upon LM. LL dash is the thickness of the glass slab T upon LM. So here LM will be T upon cos R. We are putting the value of LM from equation 3 in equation 2. We get MS lateral shift will be LM sin delta. LM की जगह हमने equation T से लिखा T upon cos R and delta will be from equation 1 I minus R. Thickness of glass slab is T. Now lateral shift here will be given by T upon cos R sin I minus. Lateral shift or lateral displacement depends on the thickness of the glass slab, angle of incident, or indirectly depends on mu. Refractive index, this are again depends on wavelength by the Cauchy formula. Here ABC are the constants. So it depends on mu depends on lambda. So these are the factors. These are the factors on which lateral shift. Reversibility means suppose this is the incident ray coming from the first medium, say air, to the glass to again air. Suppose we put it here a mirror, plane mirror in this way. This ray is incidenting normally, and normal incident never bends. So here from the mirror it is bouncing back, tracing the same path. This is called reversibility. Here in reversibility, if it is moving the refractive index in relative term mu of glass with respect to air, the reciprocal of air with glass. If mu of G with water can be written as mu of G upon mu of W with respect to vacuum or air here. If we multiply, suppose there are three medium A, B, C, D of mu of B with respect to A, mu of C with respect to B, then it will be cancel out, will be first and the last. Mu of C medium with respect to A medium. Suppose red color wavelength is more than violet color because of the reciprocal by Cauchy formula here. Mu of R will be lesser than mu of violet color. Red color mu less than violet color. So if frequency remains the same for all sorts of colors. It never changes. Speed can be changed and wavelength can be changed, but frequency remains the same out for any whether it is reflection or refraction, medium denser to rarer denser, whatever it is, frequency remains the same. Now we are discussing an important derivation case here. It is called normal shift or apparent shift, or sometimes it is called from the top if you see apparent depth, and from bottom if you see normal shift. Both are same thing. इधर नीचे से देख रहे हैं शिफ्ट हो गया, ऑब्जेक्ट इज हियर, इमेज इज हियर. ऊपर देखेंगे तो दिस इज द अपरेंट डेप्थ AI. रियल डेप्थ है AO का, लेकिन ये अपीयर हो रहा है एज इमेज, सो दिस इज द AI इज द अपरेंट डेप्थ फ्रॉम द top surface, and from bottom it is said OI. Now suppose in this diagram the ray is moving from denser medium to the rarer medium. This ray OA ray, OB ray, OA ray निकल जाएगा. This is normal incident, bend ही नहीं हो रहा. But OB, it is if it's coming from denser to rarer, it is deflecting from path and in air, so it is moving away from the normal. So here suppose I is here at C, seems this ray is coming, it seems coming from the I, not O. Actually it is coming from O object, but for I it seems to be coming from this edge I. I को ऐसा लगेगा कि ये यहाँ पे दिख रहा है I पर, not at O. Actual O फिश यहाँ पर ऑब्जेक्ट कॉइन है, यहाँ पर O पर हमें दिखेगा. So this AO is the real depth, O is the real depth, and AI is the apparent depth, OI is the normal shift. Now from figure here, Snell's law, we are moving in air from the water in relative terms. Sin I upon sin R. In sin I, you can say in triangle OAB, sin I means AB upon OB, and sin R means AB upon IB. AB cancel out, IB upon. If the angles are very small, it can be reverse कर दिया इसको, तो ये भी reverse हो. Because we know इसका formula क्या था, 1 upon WA. W with replace कर दिया इसका हमने. You know this is the reciprocal here. Here, hello. We know this is the reciprocal mu W A और mu A W. Reverse होने से ऐसे लिख दिया. So refractive index of water with respect to air, OB upon IB. Here OB upon IB is OA upon IA if the angles are very small. तो इस एंगल स्मॉल होने से OB रिप्लेस कर देंगे OA से, IB को रिप्लेस करेंगे IE. तो this is the formula here. OA is the real depth upon IA is the apparent depth. So refractive index water with respect to air is given by real depth upon apparent. So normal shift is the real depth माइनस apparent depth, real depth, apparent depth यहाँ से फॉर्मूले से मिल जाएगा real upon mu of water. कॉमन ले लिया real depth को 1 minus 1 upon mu of water with respect. This is the normal shift. अगर हम depth की बात करेंगे तो depth हो जाएगा AI, the apparent depth. Now we are taking this is the case here. Total internal reflection in short it is called TIR. The rays moving from denser medium to the rarer medium, it bends away from the normal. Angle I, angle R, away from the normal. If suppose we increase IC or IC called critical angle, then R becomes 90. It means this is the ray which grazing the surface. Grazing angle means angle R is equal to 90 degrees से just touch करता हो, graze करता हो. Suppose you further increase I, then see critical angle, there is no refraction R 90 से ज्यादा होता ही नहीं है, तो ये वापस इसी में अपने मीडियम में आ गई. इसे बोलेंगे TIR, total internal reflection. There is no refraction, is reflection total. So total internal reflection means there is no ray going out. No refraction, only reflection called total internal reflection. Internal ही reflection. Now there are two conditions must be satisfied. The ray must move from denser to rarer medium always, and angle of incidence must be more than the critical angle. If these two conditions are satisfied, then and only then we are getting the total internal reflection. From the middle figure, if here angle of incidence is IC or C, R is 90 degree. We are using this formula mu of R with respect to this rarer and denser sin C upon sin R. When what is sin C, it is the critical angle C, and R is 90, sin 90 is 1. तो हमने ऐसे उल्टा कर दिया, mu of denser medium with respect to rarer medium is 1 upon sin C. ऐसे लिख दिया sin C is equal to 1 upon mu of denser medium से water. हमको formula मिल गया relation between critical angle and the refractive. There are some applications of total internal reflection. All are normally coming in 10th class. Sparkling of diamond, mirage formation, optical fiber may come in 12th class also. Rainbow formation will discuss. Application 5 normally comes here in 12th, many times asked in board exam. This is a repeated question in board. What is this? Isosceles page. Isosceles means this one angle is 90 degree, others are equal isosceles, so 45-40. If we keep this isosceles page in this way, AB is the object, this is the ray moving, the normal incident, no deviation. At this surface, we are getting the total internal reflection once surface. So, why total internal reflection? This angle of incident here is 45 degree. This angle, and critical angle is here is 42, as more than C. So here at this surface, total internal reflection for this ray, for this also, and bound reflecting A has become as A dash, B has become as B dash. So this object AB is rotated by an angle of 90 degree. It's called 90 degree rotation. Means image is rotated by an angle of 90 degree. Here second application of the same isosceles page, 180 degree rotation. We have kept this prism like this, AB, and here ray is moving like this, BA is moving like this. At this surface and this surface, there are 2 times total internal reflection, and the object is rotated as B dash 180 degree rotation. There are 2 times total internal reflection take place. At that, here also in third case 180 degree rotation, but it is named as erected prism. Suppose we have kept like this angle again the same prism 45, and this is 90 degree. AB object क्या किया हुआ है, A is coming like this as A dash, B is coming like this as B dash. So it is erected image we are getting. It is called erected prism. यहाँ भी अगर इसे उल्टा सीधा करोगे तो उल्टा हो जाएगा, उल्टा रखोगे सीधा हो जाएगा. But this position is called erected prism. Here in both the cases 180 degree rotation, but here it is called prism. Now spherical refracting surfaces. There are some assumptions here. Refraction from the spherical surfaces may be convex, may be concave. There are some more assumptions you have to take into account, like say object, point size object lying on the principal axis, aperture or spherical surface very small, angle of incident, angle of refraction very small, alpha beta angles are also very small. We'll see here. We must learn the formula refraction from the rarer to denser medium. We are getting this formula. We will derive these cases. Whatever is the case, if the ray is moving from rare to denser, we will use this formula. Mu2 minus mu1 upon R. R is the radius of curvature. Mu1 is the refracting index of the surrounding. Mu2 is the refracting index of the surface medium. And Du. They are the image distance, object distance. And suppose it is moving from denser to rarer, इन दिस केस μ1 एंड μ2 विल बी चेंज, इंटरचेंज। ये वाला फॉर्मूला हो जाएगा जब हम डेंसर से रेयर जाएंगे। रेयर से डेंसर जाएंगे तो ये फॉर्मूला, डेंसर से रेयर तो ये हमको याद रखना। ऑल्दो वी आर गोइंग टू डिराइव ऑल द केस, एवरी केस। फर्स्ट केस वी विल सी the convex spherical surface and the real image is formed. We are moving from rarer to denser medium, means first वाला formula हमको मिलेगा। For all cases whenever we are moving from rare to denser, first वाला formula denser to rare, mu1 mu2 इसमें exchange हो जाएगा। So here we will see first case, spherical surface, convex, real image. Let us say this is air, rarer medium, refracting index mu1, refractive index mu2, denser medium, and it is glass. So this is the object here. OA is the incident ray. As it is entering from rarer to denser medium, it is bending towards the normal and it is meeting really with the principal axis. So this is called a real image. Here x, p, y is the refracting. This angle is I, angle of incident. This angle is R, angle of refraction. Alpha, beta, and gamma are the angles of incident ray. Here image ray, refracted ray, and this is the normal thing, an angle with principal alpha, beta. All the angles are very small, I, R, alpha, beta, gamma. Here using the Snell's law, mu2 upon mu1 is sin I upon sin R. If angles are small, I is replaced as sin I, R is replaced as sin R. So I upon R. After cross multiplication, we are getting this mu1 I 2R. Equation 1. Here U is minus U plus V distance, and this is R, radius of curvature is negative, these are positive. See, in this triangle, angle I and angle R. Angle I here in triangle OA and C. I is the exterior angle. The exterior angle I is equal to what? Alpha plus gamma. Here I is equal to alpha plus gamma. In this triangle AIC, R is the interior, gamma is the exterior, gamma is equal to R plus beta, so R is equal to gamma minus beta. Putting the value of I and R here in this equation 1, we are getting mu1, I की जगह ये लिखा, R की जगह हमने gamma minus beta यहाँ से लिखा. Now alpha, beta, gamma are also very small angles. Alpha is equal to 10 alpha, beta is equal to 10 beta, gamma is equal to 10 gamma approximately. This triangle 10 alpha means perpendicular AM upon OM, 10 beta means AM upon MI, 10 gamma means AM upon MC. AM will be cancelled out. In that case, say here aperture is small, means MO is PO, MC PC, MC MI PI. सारी distance हमें कहाँ से लेनी है? Pole से. And for small aperture, PM distance can be neglected. In that case, PO, PC, PI. You know from the diagram also, PO is minus U, PC is plus R, PI is plus V. If you put it here, then हमने R वाली टर्म को एक तरफ ले गए, यानी mu2 upon R, यहाँ से क्या है mu2 upon R प्लस का उधर जाके माइनस हो जाएगा, या U और V इधर ले गए. So it can be written as mu2 upon mu2 minus mu1 upon R is equal to mu2 upon V minus mu1 upon U. ये फॉर्मूला हमको मिल गया. रिलेशन बिटवीन mu1 mu2 V R, ये रिलेशन ही हमको मिलना था पहले जब रेयर से डेंसर में जाएंगे, हमेशा यही मिले. डेंसर से रेयर तो उल्टा हो जाएगा. तो दिस वाज द केस ऑफ रेयर टू डेंसर कन्वेक्स, तो फॉर्मूला भी वही ऑब्वियसली यही मिलना था. अगर डेरिवेशन में नहीं आता समझ जाओ आपने. सेकंड केस हियर कॉन्वेक्स सरफेस, बट वी आर गेटिंग हियर वर्चुअल इमेज. रेयर टू डेंसर सेम फॉर्मूला मिल. नाउ here this is air, mu1 tensor plus mu2 object is here closure. previous case से उसे थोड़ा पास में रखा. तो suppose OA ray is incident ray bending towards normal. इतना पास में है कि ये बेंड होने के बाद प्रिंसिपल एक्सिस, इट मींस दिस प्रिंसिपल एक्सिस एंड दिस रे AB व्हिच आर डाइवर्जिंग इन नेचर. तो ये एक्चुअल में नहीं मिलेंगे, रियलिटी में नहीं मिल रहे हैं, बट ऐसा लग रहा है अपेरेंटली ये मिल रहे हैं. तो यहाँ पे अपेरेंट इमेज मींस वर्चुअल इमेज मिलेगी आई. नाउ वर्चुअल इमेज इज फॉर्म्ड हियर यूजिंग स्नेल्स लॉ अगेन, mu2 upon mu1 equal to sin I upon R, sin R. Angles I and R is small, so it is I upon R. Cross multiplication 1I is equal to mu R. Now I and R फिर से अल्फा बीटा गामा की टर्म में लिखना है. एंड ट्राइंगल OAC I is the exterior angle, so I is equal to alpha plus gamma. And similarly, triangle IAC, R is equal to beta plus gamma. IR की वैल्यू हमने इसमें वन में पुट, IG की जगह ये, R की जगह. Now alpha beta gamma are also very small. Alpha is 10 alpha, 10 beta, 10 gamma. AM upon MO, M upon MI, M upon MC पुट कर दिया. As aperture is small, so MO को PO, MC को MI को PI लिख दिया. AM कैंसिल हो गया. Now with sign convention, Q PI माइनस 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 यू माइनस पी आर प्लस आर कर दिया. अब मैं फिर से आर को एक तरफ ले गए तो म्यू टू वाला में प्लस है, उधर जाके माइनस हो जाएगा, एंड यू वी को इधर ले लिया. तो अगेन म्यू टू माइनस म्यू वन अपन आर इज इक्वल टू, ये इधर लेके म्यू टू अपन minus mu 1 upon u. सेम फॉर्मूला वी आर गेटिंग फॉर रियल टेंसर. रियल टेंसर का कोई भी केस हो यही सेम फॉर्मूला आएगा, नहीं आता है तो समझ जाए गलती हो गई. नाउ वी आर टेकिंग हियर कॉनकेव स्फेरिकल सरफेस एंड वर्चुअल इमेज, बट अगेन तो नहीं भूलना है रियल टू टेंसर सेम फॉर्मूला आएगा, बट वी हैव टू डिराइव. जो भी केस है वही लेना है, मन मर्जी नहीं कि हमको तो आता लिख दिया एग्जाम में नंबर कट जाएंगे. जो केस पूछा जाए स्पेशली वही डायग्राम वैसे ही करना. डेरिवेशन करीब करीब फोटोकॉपी है, वैसे ही करना है, सेम प्रोसीजर सेम आंसर ऑल्सो, बट रे डायग्राम गलत हो गया तो बिना रे डायग्राम के आप डिराइव भी नहीं करो. रे डायग्राम को सही से मानना चाहिए. हियर ओ रे इज entering from rarer to denser, bending towards normal, but this ray refracted not meeting with principal axis seems to be coming from here I. So this is the image I. This is the object angle alpha, image angle beta, and gamma is the normal is making with principal axis gamma. I Snell's law mu 2 upon v1 sin upon sin r. I are small, so I upon r cross multiplication we get getting the equation 1. यहाँ तक बिल्कुल वैसा का वैसा ही है, फिर भी वैसा ही है. I को r को हमें रिप्लेस करना है इन ट्राइंगल OAC. Gamma is equal to I plus alpha, so I is equal to gamma minus alpha and R is equal to gamma minus beta. पुट कर दिया इसमें. यहाँ पे फिर से अल्फा बीटा गामा स्मॉल है. अल्फा 10 अल्फा एम अपॉन दिस, बीटा एम अपॉन एम आई, गामा एम अपॉन एम सी पुट कर दिया. अपर्चर स्मॉल है, एमओ को पीओ, एम आई को पी आई, बिल्कुल वही रिपीट. कैंसिल करने के बाद हमने एम सी को एमओ को एम सी पी से लिख दिया, पीसी पीओ पीसीआई. विद साइन कन्वेंशन पुट कर दिया वैल्यू, आर को एक तरफ यूवी को दूसरी. फिर से वही सेम फॉर्मूला डिराइव हो गया. अब हम ले रहे हैं डेंसर टू रेयर मीडियम. क्या इस फॉर्मूले में म्यू वन म्यू टू एक्सचेंज हो जाएंगे, बस ये फॉर्मूला याद है तो दूसरा अपने आप याद है, म्यू वन म्यू टू चेंज एक्सचेंज. वी आर गोइंग टू डिराइव दिस केस. रिफ्रैक्शन फ्रॉम द डेंसर टू रेयर मीडियम, वन म्यू टू एक्सचेंज होगा. Convex spherical surface and the real image. If the object now placed in the denser medium, class mu2 is the refractive index in here, rarer medium, refractive index is an object is here. The OA ray is incident ray, it is coming from denser to rarer, bending away from the normal and meeting at point I. Principal axis. So this is the real image. Real image. Using the Snell formula, mu1 upon mu2 sin I upon sin R. ISR is small, so sin I is I, sin R is I. Why see here? Because we are moving denser to rarer. Second से first में जा रहे हैं, तो mu1 upon mu2 first से second में, तो mu2 upon mu1 is this case. The difference. After cross multiplication we are getting equation 1. फिर से वही IR को हमें अल्फा बीटा गामा के टर्म में लिख, अल्फा बीटा गामा को 10 अल्फा 10 बीटा 10 गामा लिख, फिर से अपर्चर को स्मॉल करना और साइन कन्वेंशन वही चीज बार बार रिपीट है, केवल रे डायग्राम ही चाहिए. तो आई एंड आर यहाँ से पुट करेंगे. आर की जगह गामा प्लस बीटा, आई की जगह गामा माइनस अल्फा फ्रॉम द फिगर, और फिर 10 अल्फा 10 बीटा 10 गामा. एम कैंसिल हो गया. अपर्चर कम होने से एमओ को पीओ, एम आई को पी आई, एम को लिख दिया. नाउ आर को एक तरफ ले लिया. यहाँ पे हो जाएगा म्यू वन या माइनस जाके प्लस हो गया, ये माइनस है. म्यू वन माइनस म्यू टू वन आर म्यू वन अपॉन वी माइनस म्यू. देखिए अब पिछली केस से रेयर टू डेंसर वाले से इसमें म्यू वन म्यू टू एक्सचेंज हो रहा है. यानी हमको ये भी मालूम है कौन सा केस है, क्या आंसर आएगा, कौन सा फॉर्मूला डिराइव होने वाला है, वो हमें पहले से मालूम है. तो अगर कहीं गलती है तो चेक कर लीजिए कहाँ आपने. रे डायग्राम गलत है तो फिर गलत होने का चांस है. डायग्राम कुछ बहुत सिंपल है, इसलिए एक बार दो बार ड्रॉ करके जरूर. So we are discussing the convex surface, virtual image, denser to rarer medium. This is the object inside the glass denser medium, the refractive index moving away in the air, mu1. So OA ray bending away from the normal from glass to air, so it seems coming from I. I is the image. Snell's law, mu1 upon mu2 is equal to sin I upon sin R is equal to I upon R as angles are small. So after cross multiplication, mu1R is equal to mu I. This triangle CAO, I is equal to alpha minus gamma, and similarly R is equal to beta minus gamma. Triangle CAI. Putting the value of R and I here. Now again alpha, beta, gamma are small. So alpha is tan alpha am upon mu. Beta tan beta am upon mi. Gamma tan gamma am mc. Alpha beta angles are small. So alpha is equal to. Now put it here. Am cancel out. Now aperture is small. So MO is PO, MI is PI, MC is PC. With sign convention, PO is equal to minus U, PI is equal to minus P equal to minus R. Here. So here mu1 upon minus mu2 upon R. इसको mu2 इधर ले गए. So mu1 upon P. And here minus mu2 upon U. So this is the formula from denser to rarer medium. And denser to rare के लिए हमेशा यही same formula है. Now this is the last case here. Concave spherical surface denser to rarer virtual image. So this is the diagram of concave spherical surface. Here from glass to air object is in the denser medium. OA ray incident ray is the normal here. Denser to normal bend हो जाएगी away from the normal. So this ray seems to be coming from I is the virtual image alpha, beta, gamma, IR. तो हमको फिर से वही स्नेल्स लॉ mu1 upon mu2 sin I upon sin R, IR स्मॉल होने से क्रॉस मल्टीप्लिकेशन में ट्रायंगल OAC एंड IAC I और R की वैल्यू हमने अल्फा बीटा गामा की टर्म में लिखी. फिर से tan अल्फा tan बीटा tan गामा वैल्यू पुट कर दी. M कैंसिल करने के बाद तो MO को PO MC को MI को PI लिख दिया बिकॉज ऑफ अपर्चर स्मॉल. विद साइन कन्वेंशन हमने यहाँ पुट कर लिया. हमको फिर से डेरिवेशन mu1 माइनस mu2 अपॉन R इज इक्वल टू mu1 अपॉन P माइनस mu2 अपॉन U. कैंसर टू रेयर. ये हमने रे डायग्राम देखना है, बाकी तो है बार बार वही सेम रिपीट. Hello, we are discussing the lens maker formula. This is the biconvex lens. The radius here is for first surface R1 and for second surface R2. And O is the object moving from air to glass, rarer to denser medium, and is refracted and making an image here I dash. If suppose second surface is not there. Now for second surface I dash image act like object and final image is formed at I. Now here the I dash is the B dash is the intermittent image I dash and this is the distance for intermittent image. For first surface moving from rarer to denser medium, rarer to denser का ही formula लगेगा. mu2 minus mu1 upon r1 upon v dash is the intermittent image distance minus mu1 upon u. Object distribution 1. Now this I dash acting like object for second surface x p2y. Say for second surface x p2y it is moving from denser to rarer medium. Denser to rarer का formula लगेगा. And mu1 minus mu2 upon r2 for second surface and mu1 upon v this is the final image minus mu2 upon v dash this is the intermittent distance for intermittent edge. Equation 1 and 2 from on left surface, right surface. If we are adding these two equations, this will be cancel out and then taking here mu2 minus mu1 common remaining in the bracket 1 upon r1 minus 1 upon r2 and here mu1 1 upon v minus 1 upon u. If we divide by mu1 here it will become mu2 upon mu1 minus 1 in bracket 1 upon r1 minus 1 upon r2 1 upon v minus 1 u. Suppose we are writing here mu2 upon mu1 तो हमने mu लिख दिया. This is the refractive index of glass with respect to the surrounding. Then this becomes 1 upon v minus 1 upon u. formula होता है 1 upon f. So we have got the fourth equation and this is the formula for lens maker formula. we have derived this formula 1 upon f is equal to mu minus 1 bracket 1 upon r1 minus 1 upon r2. Here r1 r2 are the radius of curvature for first surface and for the second surface. Now lens maker formula for the concave lens. Here first surface x v1 y1 x v2 y2. Concave surface first, second. For first is the radius of curvature r1. For second surface is the radius of curvature 2. This is the object distance u, and this is the image formed here, intermittent I1, due to the diverging ray somewhere here at I1. And I1 is the image act like object for second surface x2. For first surface x p1 y1 from rarer to rare to denser का ही फॉर्मूला लगाएंगे हम लोग μ2 अपॉन v माइनस μ1 अपॉन u इज इक्वल टू μ2 माइनस μ1 अपॉन r1 फॉर सेकंड सरफेस नॉट डेंसर टू रेयर का फॉर्मूला लगेगा μ1 माइनस μ2 अपॉन r2 इक्वल टू μ1 अपॉन v फाइनल इमेज माइनस μ2 अपॉन v1 which is the intermittent image I1. Now we are adding equation 1 and 2. We are getting this μ2 upon v1 is cancel out from both the equations. This one cancel out. So here the remaining will be μ2 minus μ1 common here 1 upon r1 minus 1 upon r2 equal to μ1 1 upon v minus μ1 से डिवाइड कर दिया ये मिल जाएगा हमको μ2 upon μ1 minus 1 1 upon r1 minus 1 r2 तो हमने फिर से म्यू लिख सकते that is the refractive index of the glass with respect to surrounding or μ2 of the glass μ1 of the surrounding maybe air, maybe other, maybe liquid also. So we have derived this lens maker formula for the concave lens. Same formula is coming here. Now derivation of lens formula. Lens formula is 1 upon f equal to 1 upon v minus 1 2 is the same formula is coming for each and every case for lens. First case we have taken convex lens and the real image. So suppose subject AB placed beyond 2f, we are getting the final image in between f and 2f. This is real image, inverted image and diminished image. So similar triangles. There are two pairs of similar triangle ABC and A dash B dash and A dash B dash F C D F. For similar triangle, corresponding ratio of the sides for ABC A dash B dash C. Here A dash B dash upon AB, the ratio here is A dash upon A. Now second similar triangle A dash B dash F and C D F. Here again the ratio corresponding ratio A dash B dash upon A C D upon CD because AB and CD they are same. Corresponding side ratio FA dash upon CF. FA dash को हम सारी डिस्टेंस हम C से ले रहे हैं. FA dash को चेंज कर दिया CA dash minus CF. Now from equation 1 and 2 the left hand side same, so right hand side must be same. Equating the right hand side of equation 1 and 2 we are getting CA dash upon CA. A dash minus CF. Here now putting the chances sign convention A dash is V A minus U V minus F upon here cross multiplication we get VF equal to minus UV minus plus UF. तो इधर ले गए and हर एक टर्म को मैंने UVF से डिवाइड कर कैंसिल होके 1 by F is equal to 1 by V minus 1 by U. This is the lens formula. Now from equation 1 here is the equation 1 size of image A dash B dash upon size of object AB is equal to CA dash upon CA. CA dash is V, CA is minus V. This is the formula of linear magnification. Can be written like the ratio of height of the image upon height of the object. Lens formula equation 3 and magnification formula. The same lens formula we are going to derive for convex lens and the virtual image, not the real image. Here we know if the object is placed AB in between optical center and the focus, we are getting the virtual image. See the parallel ray passing through the focus and one ray passing through the optical center is not bending at all. These two diverging rays are not meeting actually, but apparently they are meeting at S. So we are getting the image, virtual, correct and magnified image A dash B dash here, same side. So again similar triangle A dash B dash C and ABC, the corresponding side ratio A dash B dash upon AB is equal to CA dash upon CA and other triangle ABF and A dash B dash F. Corresponding side ratio A dash B dash upon AB, always A dash B dash upon AB, size of image upon size of object. AB and CD both are same. So now corresponding side ratio A dash F upon CF. Now A dash F can be written as F plus C dash. So here from equation 1 and 2 again, left hand side A dash B dash upon AB same. So right hand side must be same also. So here C dash upon CA, C dash plus CF upon CF. By sign convention putting the distances, C dash is minus B, 1 minus U minus B plus CF is focal length F. Here after cross multiplication, V equal to UV minus and plus U. So it can be written like UV is equal to UF plus minus VF, dividing each term side by UVF. Now cancel out 1 by F equal to 1 by V minus 1 by U. This is the length formula. From equation 1, linear magnification formula, A dash B dash upon AB dash upon A minus V upon minus, cancel out minus and V upon U. The formula for magnification can be written as height of image upon height of object also. Now this is the formula for lens formula, and concave lens, always we are getting the virtual image irrespective of position of AB. Anywhere if you put we are getting always virtual image, erect image and diminished image A dash B dash. For similar triangles ABC, A dash B dash C. For similar triangle, A dash B, triangle ABC and A dash B dash C. Corresponding side ratio A dash B dash upon AB is equal to C A dash upon CA. For second similar triangle, A dash B dash F and CDF. Again, same ratio A dash B dash upon AB, AB is equal to CD. Here, F A dash upon F A dash can be written as CF minus CA dash. Now from equation 1 and 2, left hand side is same here, equating the right hand side, CA dash upon CA equal to CF minus CA dash upon CF, putting the chances with sign convention, CA dash is minus V, CA is minus U, minus F minus F, so V upon minus minus cancel हो गया, minus F minus V इधर से cancel हो गया, F minus V upon F, we are getting this. And after cross multiplication, here after cross multiplication, VF is equal to UF minus UV, और कर दिया करेक्ट टर्म को मैंने UVF से डिवाइड कर दिया, 1 upon F is 1 upon V minus, so this is answer. And lens maker formula, M is equal to A dash B dash upon AB, A dash upon A minus cancel okay, we have to. It can be written as height ratio, height of image upon height of object. We have derived lens formula, same for all the three cases. Now, power of a lens. Power of a lens is defined as the ability of the lens converge a beam of light falling on the lens. It is measured as the reciprocal of a lens. F is equal to 1 upon F. The SI unit here is diopter. If we are writing the focal length in meter, the power formula is 1 upon F. We are writing here focal length in centimeter. The power of the lens can be written as 100 upon F because we are writing focal length in centimeter. Now, power is positive for convex lens where focal length is positive. Power of a lens, concave lens is negative because focal length is negative. Combination of lenses. Suppose there are many lenses, like say here 2 or 3 lenses, focal length f1, f2, f3, power is p1, pt. In contact, then power will be added up. Total power will be p1 plus p2 plus p3, and focal length is reciprocally added where multiplication is multiplied. Suppose there are 2 lenses, convex lenses, focal length f1, f2, they are separated by distance of d, then the focal length formula effective will be 1 upon f plus 1 upon f1 upon f2 minus d upon f1. So this is the power formula P, reciprocal of focal length. So P is equal to P1 plus minus d upon P1 2 or focal length. 1 upon f equal to 1 upon f1 plus 1 upon f2 minus d upon f1 f2. Here is the gap between them. We have to derive this formula. There are 2 lenses in contact. We have got the relation of final total focal length F12 given by 1 upon F2 is equal to 1 upon. We are going to derive this. Let there are 2 lenses L1, L2 contact, center of curvature C1, C2. Focal length is F1. That this is the O is the object. O this ray, suppose OA ray by incident ray from the first lens, it is converging and finally it is making image I dash, which is intermittent image for the first lens. For the second lens, this I dash image is as the object and दोनों का एक साथ फाइनल इमेज हो जाएगा. I is the object distance, is the intermittent phase distance, and V is the final phase distance. For length L1, we know the formula 1 upon F1 is equal to 1 upon V dash minus 1 U. V dash is the intermittent image का distance है dash. For lens 2, this V dash or I dash image is the object for the second lens. 1 upon F2 is equal to 1 upon V minus 1 upon U. U की जगह V dash ले रहे हैं. I dash is image act like object for the lens. From equation 1 and 2, if we add 1 upon V dash will be cancelled out and it will be 1 upon V minus 1 upon U. If suppose these two lenses are replaced with single lens, focal length is let F, so it will be 1 upon F is equal to 1 upon V minus 1 upon U. Equating equation 3 and 4, we are getting the relation 1 upon F equal to 1 upon F1 plus 1 upon F2. Power is added up. By the way, say there are two lenses, one is convex, other is concave. V1 minus because concave की power negative है and focal length यहाँ पे negative. have taken here in modulus. Concave की focal length यहाँ modulus ले लिया थी लेकिन यहाँ minus. Now come to next topic, prism formula and the angle of deviation delta. Delta is the angle of deviation, the exterior angle in the triangle PL. Here is the KL is the incidenting ray, LM is the refracted ray, and MS is the finally emergent ray. Here angle I1, I2, R1, R2, and delta is the angle of deviation. For the vector angle, it can be written as delta equal to I1 total minus R1. Similarly, I2 minus R2. Delta can be written as I1 plus I2 minus commonly R1 plus R2 equation 1. In triangle LOM, R1 angle R1 plus angle R2 plus angle O should be 180. And quadrilateral ALOM, angle A plus this angle 90 degree plus angle O plus again 90 degree 360. In 90 180 minus okay 180 आ गया. Angle A plus angle O is 180. From equation 2 and equation 3, if we compare here angle 180, R1 plus R2 is equal to A and 4. That's the relation of angle R1 plus angle R2 is equal to prism angle A. Now, if you are putting this relation R1 plus R2 की A लिख दिया हमने equation 5. For a small angle A is suppose less than 10 degree, then mu equal to sin I upon sin R1, sin I1 upon sin R1, Snell's law. But angles are small, sin I1 is equal to I1, sin R2 is equal to R1. R1 is equal to sin R1 is R1. So here we cross multiply, I1 is equal to mu1, similarly I2 is equal to mu. Now equation 5 can be written with this identity, I1 plus I2 की जगह root I1 minus I2 whole square plus 4I1 I2. Suppose minimum deviation angle के लिए ये part हो जाएगा जी. I1 minus I2 0, तो I1 is equal to I2 let I. यहाँ पे हमने डेल्टा तो 0 ही हो गया. I है 4I square यानी 2I minus A. y को हम लिख सकते हैं डेल्टा m प्लस ए अपॉन. ग्राफ प्लॉट करते हैं हम लोग. एंगल ऑफ मिनिमम डेविएशन इस तरह का ग्राफ आता है बिटवीन डेल्टा एंड आई. हियर फर्स्ट आई इंक्रीज करने से पहले डेल्टा डिक्रीज होगा फिर इंक्रीज होगा. सो एट ए पर्टिकुलर एंगल ऑफ आई वेयर I1 I2 दे आर इक्वल इज द मिनिमम डेविएशन. एंड with this relation here by equation 7, I1 is equal to mu R1, I2 is equal to, if I1 I2 अगर सेम है तो R1 R2 भी सेम हो जाए. R1 R2 सेम है तो R ले लिया हमने इसको लेट R1 प्लस R2 यानी R प्लस R. 2R is equal to A, so R is equal to A by 2. एंड यहाँ से मिल गया हमको I from equation 6. So Snell's law mu equal to sin I upon sin R. I की जगह ये लिख दिया तो प्रिज्म फॉर्मूला हो गया हमारा mu is equal to sin bracket delta m plus A upon 2 upon sin I2. This is the prism formula. And this is the angle of deviation के दो फॉर्मूले आ रहे हैं 1/5 एंड क्यू की टर्म में लिख देते वो I1 प्लस I2 को हमने लिख दिया इस इक्वेशन से I1 इजिकल टू म्यू R1, I2 इजिकल टू म्यू R2, R1 प्लस R2 इजिकल टू A। यहाँ पे हमने I1 I2 की वैल्यू पुट करी, म्यू कॉमन लेके R1 प्लस R2 की जगह A लिख दिया, तो हमने यहाँ पे A कॉमन ले लिया। डेल्टा इजिकल टू म्यू माइनस 1 A if the angle is less than 3। If suppose angle is less than 10 degree, we are using the deviation angle of deviation फॉर्मूला यूज करके बाई इक्वेशन। अरे एंगल स्मॉल नहीं है, ये फॉर्मूला यूज करेंगे हम लोग 5 डेल्टा इज इक्वल टू I1 प्लस I2 माइनस A। Now come to dispersion of light। Dispersion means their white color is splitting into all 7 colors. So dispersion of light is phenomena of splitting of a beam of white light into constituent colors, 7 colors. The band of 7 colors obtained for the spectrum. Here we know Cauchy formula, mu refracting index of the medium given by A plus B upon lambda square, C plus C upon lambda 4. Where ABC are the constant and lambda is the wavelength. So mu refractive index depends on wavelength. Here there are 7 colors, white light, obscure, the maximum wavelength of red color and minimum wavelength of violet color. With this relation of Cauchy formula, for violet color lambda is minimum, for red maximum means lambda is more than lambda, for red color more than lambda, for violet color mu will be less, and mu will be less by the formula here. Delta is equal to minus 1 into A, mu is less, delta is also. Here delta for red color is less than for delta for violet color. Red color is less deviated and violet color is more deviated. You can see here in angular dispersion. Suppose this is the white light here, which is converting into 7 colors, say in the sequence violet to red, obscure. We know red color is least deviated, whereas violet color is maximum deviated. Here we are getting the 7 colors, obscure. So delta R is deviation for red color, delta V is for violet color. Angular dispersion is defined as the delta violet color minus delta red color given by equation 1. We know the relation for delta is equal to mu minus 1 into A for violet color, for red color. Put in equation 1 delta V minus delta R. It will be 1 will be cancelled out. The angular dispersion is given by mu V minus mu R into A, where angular dispersion in terms of delta given by delta V minus delta R in terms of mu. The dispersive power. Dispersive power of the prism is defined as ratio of angular dispersion divided by mean deviation. Mean deviation for the yellow color. Sometimes numericals blue color. But blue color is dominant color. Otherwise yellow color is color. Why we are taking as mean? Although it is not a mean, but it is most sensitive color to our eyes. That's why yellow color is treated as the mean color. So this dispersive power is given by denoted by omega. तो मीन डेविएशन के लिए डेल्टा हो जाएगा और येलो कलर डेल्टा इज इक्वल टू म्यू माइनस 1 A given by equation. Omega is defined as angular dispersion upon mean deviation in terms of delta. So delta V minus delta R is angular dispersion given by equation 2 divided by equation 3 for yellow color. In terms of mu can be written as डेल्टा वी की वैल्यू पुट कर देंगे यहाँ पे। डेल्टा वी की हमने ऑलरेडी निकल लिया, एंगुलर डिस्पर्सन इन टर्म्स ऑफ म्यू मैं पुट कर दिया अपॉन मीन डेविएशन, येलो कलर पुट ए कैंसिल हो। तो डिस्पर्सिव पावर इन टर्म्स ऑफ म्यू कैन बी रिटन लाइक म्यू माइनस म्यू आर अपॉन म्यू येलो कलर माइनस 1 इक्वेशन। देयर आर some cases we take, there are two prisms side by side kept in opposite sides. This white light is converting to 7 colors spectrum. Again they are meeting. So agar if white light is again coming as white light, it means there is no dispersion, and incident ray and finally emergent ray, they are parallel, there is no डेविएशन ऑल्सो। इज द कंडीशन फॉर नो डेविएशन, दोनों एंगल मिलके 0 हो गए, एक पॉजिटिव है तो एक नेगेटिव है। तो दिस द कंडीशन फॉर नो डेविएशन। इस इमर्जेंट रे एंड पैरेलल टू द इंसिडेंट रे, नो पर्सन दे आर पैरेलल। सेकंड केस मे बी व्हाइट लाइट इज कन्वर्टेड इनटू अगेन व्हाइट लाइट, सो there's no dispersion, but this incident ray is not parallel to the emergent ray, so there is a deviation. Yes, a deviation. but white light, so there's no sun. Another possibility here is dispersion, yes, and deviation also, yes. So white light is converted into dispersion of colors, and this white light mean color is also deviated. So दोनों हो रहा है यहाँ पे, dispersion as well as deviation. Fourth case, dispersion है, yes, but there is no deviation. It is very typical thing here. See, white light is converting into 7 colors. So definitely there is a sun, but there is no deviation, as the mean color here, white light and mean color, they are parallel. Mean color means yellow color. So there is no deviation as such. Overall there is no deviation, but there is definitely dispersion is there. Now scattering of light. Most of the beautiful phenomena like blue color of the sky, white color of the cloud, red sky of the sun at the time of sunrise and sunset have been explained in terms of scattering. It represents the change in the direction of the light. Intensity of scattered light is the inversely proportional to fourth power of the wavelength of the light given by the Rayleigh's, sometimes it's called Rayleigh's, the Rayleigh formula. Scattered light intensity inversely proportional to fourth power of the wavelength is verified by the Tyndall effect. Here, Rayleigh said there is no change in the wavelength in scattering. There are rainbow is the phenomenon of scattering also, as well as it depends on the total internal reflection. So sunlight is coming and our back is toward the sunlight. We are looking here and the raindrop must be there in the eye. So during the rain or after the rain, raindrop must be there and sunlight must be there. The essential condition here, you can see from the back side is sunlight, and we are looking from the two types of rainbow, primary rainbow and the secondary rainbow. In primary rainbow, in the raindrop, only once total internal reflection takes place. Here, all the 7 colors in the angle range is 41 to 43. They are sharp in color, so they are dark. So, color sequence here is bottom is violet, top is red. The second secondary rainbow. Here there are 2 times total internal reflection take place, and this is the front dull color, shade color, dull color, dull rainbow. Color sequence is reversed. Top is violet and bottom is red. Can be seen, and the angle range is 51 to 4.